Okay, so in this video and and the next one, we'll be completing the square. That's the factoring technique we'll be studying, and this definitely has a procedure to it. It's a little involved, but let's just start. Here we start out in this case with this equation, the quadratic x squared plus 6x plus 7 equals 0. Um, for To keep things tidy, bring the constant number, in this case 7, over to the right side. So subtract 7 from both sides. The idea here is isolate the x squared and the plus 6x by themselves, because a lot's going to happen with them. Um, Before proceeding any further, observe that the leading coefficient, the a, if you are familiar with that, the a, b, c, a, the a is equal to 1. That's important. That's really important. If it's not equal to 1, then we have to do things, and that will be what the next video will occupy itself with. But it is x squared, 1x squared, and so everything is cool. Now here's the thing that's not obvious at all. What you have to do is the b number, if you think of it, the coefficient, in this case the number 6, the coefficient of the linear coefficient, they call it, that number 6, you multiply it by 1/2. Multiply it by 1/2, and in that case, half of 6 is 3. Now you take that number 3, which I've now written down here in blue, and square that number. Square the result you got in the green line here. So 3 squared is 9. That 9 is going to come in to the equation right here and here. Now you're going to add 9 to both sides. You can't selectively add 9 to one side. That would throw off the balance completely. That would be a miracle. Not allowed. But you can add 9 to both sides. Now the reason for doing that is it turns out that this expression on the left side, x squared plus 6x plus 9, can be factored. It can be factored. It can be expressed as a square of a binomial, the square of a two-term expression. And I always check this here to be sure. So that's what I've done over here in red. I've written out, okay, well, am I really right? Is it true that x plus 3 quantity squared ends up being x squared plus 6x plus 9? And it does. So this is all very good. The right side is just you just add it up, however that turns out. It turns out that a negative 7 plus 9 is 2. Great. And now we're right back to the type of problem or situation we had in the video before, which was using the principle of square roots. We have a squared expression equaling a constant. So you take the square root of both sides. Don't forget the plus minus. Hello. And what that process does is it cleans out the squaring. You're taking the square root, which is the opposite of squaring, and thus you're left with a plane, in this case, x plus 3, equaling plus or minus square root of 2. And then in this case, subtract 3 from both sides. And this should be an expectation that normally you'll have two answers, and I highly recommend you separate them out in the way I've done here to clarify to yourself that there are two answers. You're going to have this negative 3 plus square root of 2 and a negative 3 minus square root of 2, because it's important not to lose solutions. I'm trying to think if there's anything else crucial here. I don't think so. So let's go to the next example. I try to have enough examples with enough variety so you'll see how this all works. So here we go. Maybe let me bring back the first one, because I should give you a chance to pause to write this down. I am kind of rushing through, and that's a sin. So I'll just leave that there for a few seconds so you can pause your video and write this down as you need. Okay, hopefully that's been sufficient. Okay, now the next example here, example 2. All right, so here we go. All right, let me see if I can get this laid out here. Oh, there we go. All right. Okay. All right, so there we are. X squared plus 8x minus 9 equals 0. Okay, so what I should say is the first step is make sure your leading coefficient is 1, and it is. then the next step would be, if your constant is with the other terms as it is here in the situation, get that constant over to the right side. And then notice that doing this in a color-coded way deliberately to be helpful is 8 is the number you need to multiply by half, and a half of 8 is 4. Then you take that 4 and square it, and the square of 4 is 16. 16 is the magic number, if you want to call it that. It needs to be brought in to both sides of the equation. You're going to add it to both sides. It's always going to be adding. All right, so the next line here shows that I've now added 16 to both sides, and with that, the left side here can be factored. The left side of the equation here can be factored into the square of two terms, and you know, you can always check this verbally. You can say, okay, x, if I were to multiply this out, x squared, x times 4, double it, 8x, 8x, 4 squared, 16, yes, everything is good. 9 plus 16 gives us 25. Wonderful, 25 is a perfect square, just saying. Take the square to both sides. Don't forget the plus minus. Since 25 is a perfect square, I immediately thought, okay, well, let's compute that. The square root of 25 is 5, so plus or minus 5 is on the right side of the equation. Next, you notice how the square root, taking the square root of a square cleans out all that stuff. We now just left with the x plus 4 equals plus or minus 5. Subtract 4 from both sides. Then being careful to make sure that we're going to have two answers, and so I'm computing these two answers in the second to last line there, and then just computing negative 4 plus 5 is 1, and then negative 4 minus 5 is negative 9, and that's it. And I'll leave that there for just a second. Maybe if I can bring that back up, yeah, just in case you would like to write that down. Okay, so we'll now next go to example 3 of completing the square. And here we are. All right. Now this is x squared minus 6x minus 11 equals 0. So first step, make sure leading coefficient is 1. It is. Then add the 11 to both sides to get the constant over on the right side. Next step, which I'm always doing in green here, multiply, take this number, which in this case is negative 6, multiply it by half. Half of negative 6 is a negative 3, and then square the negative 3 and you get a positive 9. Yes, if you're starting to see a pattern here, this squared number that you're squaring, hello, which means it's always going to be positive. So yes, you'll always be adding a number to both sides, in this case a positive 9. And it just so happens that 11 plus 9 gives us 20 on the right. And then on the left side, careful about this would be x minus 3. Notice you have a minus 6 here. That means you'll have subtraction going on inside your squared expression here. And then take square to both sides. The only slightly new thing here is just that this issue of the square root of 20 is a radical that can be reduced. And in red, that's a reminder how to do that. 20 can be expressed as 4 times 5. 4 is a perfect square, and therefore you can say that square root of 20 is 2 times square root of 5, and that is common practice in mathematics to do that. So that's why I'm insisting on it here. And then the rest here is pretty much like the other problem. You simply add 3 to both sides and just make sure that you're clear there are 2 separate answers there. And that will do that. Let me just pause and again, in case you need to write anything down, you can pause your video. Oh, right. The last, for this video, last example is this one here. It looks very much like the one we just did in the sense that same numbers almost. X squared minus 6x plus 11 equals 0. The problem 3 we just did had minus 11. But same procedure, make sure your leading coefficient is 1. It is. Bring that constant over to the right side. It is. Now you do the same process of taking half, multiplying by 1/2 the number here in front of the x, so that's -6. And just like the problem we just did, you get, once you square the -3, you get 9. So 9 is going to come into the equation. So nothing new there. It's very formulaic, this process. And then we have our squared binomial going on here. See, -11 plus 9 is -2. And then we take the square root of both sides, but as you're observing, right, we're getting a square root of -2, a negative number. And from 3.1, that means we can convert this to using the letter I. This is what's called an imaginary number. Other than that, the same idea is like, well, I've cleaned up this square root, square stuff on the left side. We're just going to add 3 to both sides. And there we are, 3 plus or minus square root of 2 times I. And here it's even more important to separate out the answers along these lines here. That's why I've been doing it all from scratch every time, writing them out this way. Because here, this way of writing the complex numbers is a common practice in mathematics. Usually on Pearson and other places, you'll see write the answer in the form of a plus bi. So your I term is off there to the right, and the term that doesn't have I is on the left, and that's exactly the pattern you're seeing here. And so I'm trying to follow that because that's just and there's a good reason for it, for graphing, which we won't be covering in this class, but you can graph these complex numbers, and there's a good reason to separate out the a part and the bi part as they do here. Let's see. So that should complete this video. This video has been concerned with completing the square, where we started off with the leading coefficient being 1. And the crucial question is, what if it isn't? What if it's not 1? It's something other than that. That's what the next video will cover. And I'll just leave this for a few seconds more, and you can pause the video if you need to do any more writing of this problem. And I think that will do it. Thank you.